Hey, thank you all. Before I start, I'd like to ask the audience a couple of questions, like, for instance, just to get a level set of who's in the room. How many people are on this, this is a spectrum of folks who are involved in this community. Consider yourself developers of pipelines other people will run. Raise your hand. And how many people are in the I'm just here to learn how to run this stuff so I can get my job done side? Okay, great. So both of y'all here, hopefully, these talks have been really fantastic from my point of view. They sort of stole all my thunder because a lot of the stuff that I was going to mention is covered here. So I did a refresh of my slides last night, and sort of want to give my spin on and make, one of the secrets of speaking and public speaking is that you repeat a point over and over if you really want that audience to go home and remember it a few days later, right? So I'm actually just going to repeat some of the previous talks and things, right? So writing workflows is one skill set. Running them on your own data is another skill set. And a third skill set is the operator, right? The folks who actually are responsible for making sure this thing has a particular price performance envelope that's meeting a business need. And sometimes operators have different concerns than either of the other two camps, right? So first things first, if you are an operator, if you are a group that's running in production, I cannot stress enough how important it is to have a representative workflow and a data set that you run not every day, not every week even, but you run semi-regularly as you're deploying pipelines on revisions to make sure that you're getting the result that you're supposed to get, right? So it's, NFCore is a fantastic exemplar for CI/CD on small revisions that use a very small data set because they need to move fast. They're running this thing all the time. It would be cost prohibitive to run the full GATK practices on 300x coverage genomes every time you put out a point build. That's just not something you should do unless you've got a lot of money. And as we know, biotech took a dive. So everybody's under a price concern. So small tests for CI/CD for minor versions, but if you're releasing major versions, then you should have real data with known results that you can run regularly to get at the real price performance of what your workflows are going to be given a certain operational environment. So have a real life data set, know the result to make sure you're still getting the right answer, and baseline numbers on a particular aspect if you're going to change anything in the future and assess what you're going to change. And big props out here, previous speaker, Andres, for mentioning this in his talk and as a best practice. And if you're an SI, a system integrator, and creating workflows for folks, just keep hammering in that point to your clients that this is something that they should be running regularly, paying attention to, have that process for getting at a result on a real data set, right? So one of the questions I get, because I'm at AWS, I get a lot of people running on different types of infrastructure. I also have background in informatics, bioinformatics, and I used to run HPC infrastructure. So this is my view of the world. If you've ever seen, a few years ago when we were still trying to describe what is cloud computing, and somebody came up with pizza as a service, right? So if you want pizza, you could start with flour, make your dough and whatever, or you could just go to a restaurant, Pizza Hut, get your big red cup and your pizza slice and eat there, right? And it's the same thing for when you're looking at operations, from buying your own physical infrastructure and racking it if you've got data center space, up through hosted virtual machines where the responsibility model is you're taking care of the operating system, all the packages that run on it. And then you've got managed service primitives. So what do I mean by that? That's something like a cloud provider like AWS or others providing a batch semantics on top of some orchestration, right? So AWS batch is a great example of a primitive. It's there at the level of, this is a core business need like Slurm scheduler or AWS batch, but it's managed infrastructure for me. I don't have to worry about managing. I just have a queue that I submit to. And then you have value-added services and products. This is actually where most people are in the community, right? They're looking at using secure platform with my own AWS account, or other platforms, other service providers membered with my own AWS account and my own data lake. And you have a mix of having a value that is important for the business. I don't necessarily want to operate it, but I still want to have some insight into the infrastructure going on. And then you have end-to-end products like Secure Compute or other platforms that are really like, this is my sole source. I could care less about what's underneath the hood. I just want to run my workflows and have them work and you know, shut up and take my money. So, Lorena, thank you for this question. Why am I even doing this? If you ever ask yourself, why am I ever doing it? Why am I even doing this? This is not really my day job. This is not a core competency. It does not matter for our business. We're taking on a business cost with almost no value. That's a good sign you're a little too low on the stack, right? You should just move up and find out what those products are and move yourself up the stack, because the most expensive resource in your company is the people who are there, full stop, right? So if you're wasting people's time, you're wasting your company's money. All right, and like I said, you've got more flexibility or perceived flexibility, whether you take advantage of it or not, down at the bottom, but you also have the responsibility of it all. So further up the stack, you're handing that responsibility off, you're handing some of the perceived flexibility off, but it might be worth your while, right? So where do I run? Individual question, just keep note of those 2 arrows. Data sources, right? So a lot of big questions that I get is, when I run my workflows, what should be my default operational mode when I'm looking at where to store data, where to pull down, what services do I take advantage of, right? There's this whole object storage versus POSIX. Fusion is basically why not both, right? My advice to folks is the baseline. What is your baseline? Your baseline should be Fusion plus EBS backed by S3. Like, full stop if you're on a secure platform. If you're not on a secure platform, find something that is equivalent to that baseline, which is an object storage being backed by pulling down in the user file system the data that you need at each node, right? Consider parallel file systems for a couple of reasons, right? When you start moving away from that baseline, there are a couple of things that you should look at. Is if, again, for your representative workflow, if you're finding that you're underutilizing the compute that you access because you're waiting on transitioning that data from your object storage onto local storage, that's a sign that parallel file system might be worth it for your organization. Trade off with people's time in managing it, right? FSX for Luster, if you have random access patterns, so object stores and things there's a lot of stream processing in bioinformatics, so it works great. If you have a workflow that is not stream processing, if you have a lot of random reads, a lot of random writes, you're going all over the place, then parallel file systems that are tuned for this sort of access patterns might be worth your while. There's Weka, there's FSX for Luster, there's a lot of different providers, right? And the final consideration is, when should you move away from just object storage with some fuse layer, is if you're taking advantage of that data in some other system. For example, if you're using SageMaker and SageMaker notebooks, it has the backing store with EFS. You can mount that same EFS volume as you work with Nextflow systems and really figure out how to do that, right? So, cost of operations, going back to what I was saying. The top figure on the top, let's see, your left, is basically a stacked total cost of operations, right? Where the orange bar on the top represents your compute costs and local storage costs with EBS. The bottom one is S3, and as you're going more frequent runs, your cost is just going to go linear with the frequency of those runs, roughly, right? And if you're looking at a parallel file system, especially something like FSX for Luster, which is acting as a front-end cache to that backing store, you might be paying for the provisioned storage, but your total cost of what EBS is, plus the amount of time that you run on the CPU, shortens. So that grows at a slower rate. And at some point, based on the frequency and cost of your analysis, you're going to hit a point represented by that green dot where those two lines converge and start to sort of flip. That's the point when you should really consider is a parallel file system worth it for me? And it's highly dependent, again, on your workflow and how often you run it. The how often I cannot stress enough, because that really is going to determine what those two lines, where they intersect. Great. So that's it for data. There's probably more. If you've got more questions, I'm not going to take up my whole time probably. So please, in the Slack channel, I'm happy to answer any questions or in the break. Compute resources. What should you look at for compute to go away from that golden path? When should you consider it? There's different CPU architectures, right? Like all cloud providers have a ton of different options. We come out with different CPU architectures almost yearly, if not multiple times a year. And I am absolutely so excited about our work with Sakara and ARM to get bioinformatics applications to use Graviton, not only for the performance per watt, but also absolute performance numbers that we're looking at. There are some algorithms, so we've been doing some tests behind the scenes, and we'll be publishing these sort of numbers along with the group when we get there. But there are some algorithms that are at parity with x86 infrastructures that say, we're about the same runtime. Price will differ between those. So price performance ratios will prefer a ARM-based infrastructure at that point. There are some that actually run faster, and there are some that just are nowhere near the performance of what you can get from an x86 infrastructure. And again, that's dependent on the algorithm. We'll be doing some tests and putting that out. But if it works for you, great. And now you have an easy path to adopt it, which is even better. One thing that most folks don't know about is that actually our group, our HPC services group, actually comes out with specialized HPC infrastructure for certain types of algorithms, right? So we have a HPC-focused Graviton 3E. It's really a banging ARM processor for these types of workloads attached to Elastic Fabric Adapter, which is our low latency, high bandwidth MPI infrastructure, right? A lot of machine learning happens on it because you need to do distributed learning across instances. We also have AMD EPYC processors, so these are really big honkin' x86 processors. For the most part, we've found that, at least for this generation, when it's a really compute-intensive process, the x86, both the Intel and the AMD are doing quite well with these algorithms. Things are not yet compiled and optimized for ARM, but we think, honestly, that I think, this is not the opinion of AWS, this is me, I think that we are undergoing a really exciting time for low-level code optimizations, and to keep your eyes on the space to see both not just how ARM is doing, but what is the answer from AMD and Intel and how they're approaching things, because there's some really interesting blog posts about a back and forth about depending on how you compile and run your code and static analysis, you'll get better performance on one architecture or the other. Again, have that representative workflow, try it out, try these infrastructures, find the best price performance for you, and you have the option to run on all of them as needed. Right. Advanced features from a managed service perspective. Again, I work with AWS Batch, so I'm going to show you fair share policies. Like, what are fair share policies? If you've ever run HPC infrastructure, you know that sometimes you want to give priority to certain types of jobs over others. You can do that in AWS Batch. Here I have an example where I have a 2-to-1 ratio as you're looking at the head of the queue. Place the yellow jobs more often, or actually I have this reversed. Sorry. I changed the colors on this and I changed the wrong colors. All right, I had a 2-to-1 blue, it should have been blue, 2-to-1 placement priority on blue. And you can see the real life data actually shows it, not my janky PowerPoint showing. Just reverse those two colors in your head. Unless you're colorblind, I did not do this wrong. But what it shows is that, I submitted the blue jobs later an equal amount, and it was drawn down faster because you're placing more of them on the queue as resources become available. So Nextflow Edge has added this. Really grateful. Hopefully Sakara platform will, by sometime before the end of the year, add it very easily. because they're responsive to cool stuff like this, features. Thank you, Paolo. But essentially, when should people look at something like this, right? Forge will not do this for you. You're back to doing templating, taking ownership of the infrastructure. You're still leveraging that value add from a platform, but now you're taking back ownership because you feel this is a need. So what's the trigger for the need for an advanced feature? It's basically when you run into the limits of a flexibility point that you can't overcome with the higher level service provider. And in this case, I see it a lot with the number of compute environments that you can have within a single account on AWS is restricted, and sometimes you might go over that limit. Or you have different types of workloads from the same group you want to keep in the same compute environment, but give different priorities to them, right? So those are both two sort of triggers that you want to look at and think about, okay, this might be a possible solution because we've run into this problem where it's an actual business need. Not something you should adopt off the shelf. Again, you should have a baseline, a default. When you start running into operational challenges, then you look for optimizations. And the last thing I'll talk about is budget sort of thing. I'm a bit facetious with shut up and give me your money, but just give me your money. No, it's the thing. Everybody has a budget, right? And I think there's a lot of fear and uncertainty, doubt still with leveraging cloud providers. And in fact, somebody brought it up, like, it can get very expensive. It can get very expensive for on-prem as well. That's an opportunity cost. That's a people cost, right? You're just not keeping track of it. It's not exposed to you every day. It can get very expensive because you made a capital purchase 2 years ago and you forgot about it, right? You're not seeing it every day. So the exposing of the costs is an artificial, it's artificially inflating people's heads what the total cost of operations is. And it's a human thing. You just have to be aware of that and know that there are tools to keep your life sane. And one of those are budgets, right? So for a long time, you've been able to go out and get billing and cost management. There was a whole separate console that was around budget alerts. We took a lot of customer feedback and merged these two into one billing and cost management console. And in fact, you can set up a budget. There's some really nice little templates here, like a zero spend budget. If you're an R&D organization and you're doing a proof of concept and you get AWS credits, you want to find out when the first dollar is billed, right? There's a little template for that. Great. Monthly cost budgets. Like we have a cost about, just throwing this out there, $3,000 a month that we could spend. That's our budget. If we should send an alarm, we can go over it a bit, but then we have to adjust for the next month based on what's coming in, right? So the budgets are a thing. You can set them up. You can set up alarms. Highly recommend, if you haven't done that today, go and do that today. Another cool thing is, okay, so budgets are great. What if you're still under the budget, but have a workload that was unexpected? It's out of the norm. How do you deal with that, right? And so we have cost anomaly detection. Here's a report from me. I've been doing a lot of R&D testing, but I got reports saying, hey, you've got something that's out of spec. Like, this is not your normal spend. Here's an alarm. Here's a notice. Are you sure that's okay? And you can go and investigate. So again, as an operational person, budgets, cost anomaly detection, use them, keep yourself sane. That's the last thing I'll talk about. I'll take questions. I mean, again, pay attention to things like static code analysis if you're at the far end of the spectrum of software development. If you're at the other end of the spectrum, take advantage of those value-added services, if not an end-to-end solution. And then when those don't work for you, really start looking at the underlying platform for specific features that you want to introduce carefully, and also measuring the result of that introduction. Thank you.
Well, thank you, Enjo. Just wanted to state that AWS is a sponsor of the summit, so thank you for sponsoring us. So we have a question. When should we think about using EFS versus FSX? Static read-only reference data, for example?
Yeah, so EFS and FSX, so FSX for Lustre and EFS have sort of different performance characteristics in how often your workflow will access that reference data and whether it's doing stream writing or processing or very small files versus slightly larger files. There's no real guidance other than to test it for your workload to see what performs better. The other sorts of things that you have to be aware about is one zone, like within a single availability zone versus cross-zone availability. There are different performance characteristics of either of those, EFS, and FSX is single zone. It can be you deploy multiple ones to address multiple availability zones. They still act as the cache to the same backing S3 store. It just has the cost of that allocated storage. So again, the cost model and performance models are really what you want to look at. And the last thing is the thing it integrates with, right? Again, and I'll just bring up SageMaker as the canonical example because it uses EFS as the backing store for some of its data lake and data products for analysis on its notebooks. So if you can leverage it, if you are leveraging that, then you might tilt towards EFS more than FSX. But test it, know what you're getting into.
Thank you. Another question. Can you talk about the pros and cons of using Fargate in AWS Batch for NF Core pipelines versus custom launch templates with AMI, especially considering the control over provision instance types, DBS, and so on?
Right. So a couple things. This might be going a little too deep. Fargate launch for a job and a batch job is a one-to-one correlation, right? So you're limited by the Fargate sizes, but it's a much easier billing model, right? So if your job fits within Fargate and Fargate Spot, try it out. Honestly, it's going to it's a capable platform. When you start looking at EC2 is when you are reaching a certain scale or you have specialized infrastructure like something that Fargate doesn't support, which is GPUs, accelerators, and also we can place more jobs quicker on a larger EC2 instance than we can starting up individual Fargate jobs, right? So it really depends on the service level agreement you have in term to complete, how far it scales, and also the requirements of the job itself.
What do you see as the biggest stumbling block when onboarding data scientists to AWS, especially when they do not have low-level access?
Ooh, biggest stumbling block is that they now have a job that they never signed up for, right? The why am I doing this? Like, you're never gonna get over that. But if you do, A, I'm sorry, but B, see if you can get to a higher level platform that is, if not free, cost effective to make the case that this shouldn't be your job. Like, please do that. If you are forced to now become a systems administrator, the biggest stumbling block is probably just figuring out account structure, IAM permissions, and the third one is what to use. Like, literally, what's the best practice to use? And I think, maybe we should start at infrastructure and of course special interest group to say for bioinformatics, what is that best practices to use if you're forced to be a sysadmin? So I'll follow up with Geraldine and Phil about that.
Okay, thank you very much.
Thank you.